Well, let S be a surface of the cylindrical solid bounded by x squared plus y squared equals 9. That means we have a cylinder which in the xy plane is a circle, but it's projected along the z-axis, so it makes it, of course, center would be at the origin where the z-axis comes out of the xy plane. So that's the surface bounded by that cylinder and the xy plane, and the plane z equals 2. All right, the plane z equals 2. Now that changes things, because this really is a can now. It's a can of radius 3 and height 2. And so here's the question. It's oriented by the outward unit normal vector n, and let a vector field be defined by f of x, y, z equals x cubed I plus y cubed j plus z squared k. Use the divergence theorem, Gauss's theorem, to evaluate the surface integral of f dot n ds. Okay, so according to the divergence theorem, the divergence of this vector field is the partial of the I component with respect to x plus the partial of the j component with respect to y plus the partial of the k component with respect to z. So that would be 3x squared plus 3y squared plus 2z. There it is, right there. So from the divergence theorem, if we want to evaluate this surface integral, all we need to do is, over the solid Q, find the divergence f dv. Of course, the divergence, we already have it, it's right here. So we need that. So converting to cylindrical coordinates, that might be a bit of a challenge, but notice this x squared plus y squared, that'll be handy, because that's just going to be 3r squared plus 2z. And evaluating r z dr d theta in that order, r goes from, z, we're integrating with respect to z first, z goes from 0 to 2. I'd ask you to recall what this shape was. Remember, it was a can of height 2 and radius 3. Radius 3. Z goes from 0 to 2, but r goes from 0 to 3, and we're getting the whole can, so theta goes from 0 to 2 pi. So integrating first with respect to z, we get 3r squared z plus z squared. And z going from 0 to 2, you could probably see why that comes out as 6r cubed plus 4r dr d theta, and r goes from 0 to 3, 6r cubed. Integrating that would give us something like 3 halves r to the 4th plus 2r squared, and r going from 0 to 3, trust me, we'd wind up with 279 halves d theta. Trust me on the arithmetic. And so evaluating that, theta going from 0 to 2 pi, we just wind up with 2 pi times 279 over 2, so that's 279 pi.